All right, so as promised, we're going to take a look at an infinity minus infinity problem. First, let's figure out how we know this is infinity minus infinity. First off, down here, where it says x approaches 0, this could be a two-sided limit. It gives us the same answer, even if it is. But it doesn't really matter to you guys, but just to make me a little bit happier, I'm going to say all of my x's are positive, so we're approaching 0 from the right. Again, it doesn't really make a difference in how we approach the problem. It just makes me a little bit happier for reasons we'll talk about. So, I see subtraction, so that makes me think maybe infinity minus infinity. So let's look at each of these pieces. So as x approaches 0, this first term is approaching 0 plus 1 over 0. And we know that a non-zero numerator over 0, we've been saying d and e, and that's completely true. But the reason that it doesn't exist is because a non-zero number divided by something that is getting tinier and tinier makes the result bigger and bigger. So in this case, the reason that non-zero over 0 doesn't exist, anytime we have a non-zero over 0, it's because you're either approaching infinity or negative infinity. And so that's part of why I made this approaching 0 from the right, so we would know it was positive infinity, but honestly it doesn't matter. For the other one, we'll try direct substitution first. And so there, if I plug in x equals 0, my numerator is definitely 3. And my denominator is 0 squared plus 3 times 0. And so there again, we have a non-zero numerator, but that denominator is 0. So that's another d and e. More specifically, it doesn't exist because it's a non-zero over 0. So it's an infinite limit. So that work is just how we know that this is infinity minus infinity. You wouldn't have to write that work out, but I do want to explain how we know we're in this situation in the first place. And really it boils down to this. Non-zero over 0 minus another non-zero over 0. That's the issue. So now, to deal with that, it is purely an algebra problem from here on out. Recognizing that we're in that infinity minus infinity form tells me I need to do algebra. And as I said in AP Calculus, this is the only other indeterminate form we look at besides 0 over 0 and infinity over infinity. And so it's not just random algebra, it's common denominator algebra. So, I'm just going to rewrite what I have with a little bit more space. Again, I'm saying I'm approaching from the right, you don't need to really worry about it. And I want to start by doing something that a lot of students do for these problems, which seems like it would be easier, but ends up making things a lot harder. So a lot of times students are like, oh, so this first guy has a denominator of x, so I'm going to do an x over x for the other guy. And the other guy has that weird x squared plus 3x denominator, so I'll give that to the other. This is not technically wrong at all. The trouble is that it's going to be a lot harder just to do the algebra involved here, because we would have to, we get an x cubed involved, and that's a pain. So instead of doing that, let me erase all of this stuff. It's not just finding a common denominator. Your best bet is to try to find the least common denominator. And so what we'll do is we will factor this other denominator and then consider what's missing from each. Because I notice, cool, both denominators have an x. So far, so good. But this second denominator has an x plus 3. So let's make sure we get that over here as well. And by doing that, we already have the common denominator. The x is already matched. We just tacked on an x plus 3 to get that to match. And this limit is going to be a lot easier to figure out because this algebra is going to be a lot easier. Because where we are now is leaving that limit notation. I have a common denominator, and I love factored stuff because I'm hoping I can cancel some things at the end of this. So I'm going to leave that common denominator factored. But the numerator has this subtraction. So this is where the algebra happens. So I have x squared plus 3x plus 1x plus 3 minus this 3. That's fun. There we go, minus 3. And so now it starts to look more like a very familiar problem. We have a common denominator, and just wonderful things start to happen. So the 3's cancel. And while I'm at it, I'll go ahead and factor what's left up in that numerator. Factor out an x, which is fantastic news. Because now, as we've seen so many times in these limit problems, now the algebra trick that just keeps showing up, after factoring, we were able to cancel. And then once you've canceled something, it's time to retry direct substitution. And so here, if I do my direct substitution, 0 plus 4 is 4, and 0 plus 3 is 3. That's a real number answer, and we've got it. So just to summarize, if you feel like you've got it, you can stop watching. But just to summarize what we did, first thing was we recognized that we were in that indeterminate form, infinity minus infinity, because we had non-zero over 0 minus non-zero over 0. For our purposes in AP Calculus, anytime you have infinity minus infinity, it's going to be a common denominator problem, sometimes easier than what we did here. Sometimes it uses some of the tricks we did here. But everything on the left side, sorry, on the right side of the screen is prerequisite stuff. The only thing you haven't done in previous classes is write this limit junk in front. Everything else over there is just algebra. And then this very last direct substitution step, which arguably you could say is calculus, but it's also just plug and junk in. So on homework number 4, you'll see some examples like that, but it really is a pure algebra problem once you know you're in infinity minus infinity. So I hope that helps.